Good morning. I am joining you from United States today. Hello. I hope everybody's gonna have a great day today, and thanks for coming to my presentation. I'm going to cover the IoT, the SQL Edge on Raspberry Pi today. I hope everybody's gonna enjoy the presentation. Let me go back our agenda. I'm going to cover some of the basics of the IoT before we kind of jump into SQL Edge, because there are a lot of kind of technologies you kind of need to know and learn about it before we kind of jump in, so it will kind of make sense. There are going to be a lot of technologies that you kind of need to know if you want to install the SQL Edge. So we will cover those, and then probably it will make more sense to kind of, I guess, understand the SQL Edge. So here's our agenda, and let me speak about myself a little bit. My name is Hasan Savran. I am from Cleveland, Ohio, United States. I am a Microsoft Data Platform MVP. This is my second year, and I am a currently business intelligence manager at one of the insurance companies here. I have a great experience with the web development. My last 8 years, I've been in that business intelligence, so I had a chance to kind of deal with the data a lot. I have my blog. You can check out my blog. Usually, I write about Cosmos DB, SQL Server, front-end, C#, whatever I know. I try to share my blog. Please check it out. And also, if you will have any kind of questions about any of this presentation, you can really ask me from another platforms here on this deck. So let's see. Let's actually start with IoT history. IoT actually came up, the idea came up in 80s and 90s. IoT refers to the billions of physical devices around the world that are connected to the internet. So idea came in 80s and 90s, like many great ideas, but the problem was, we did not have enough technology or the right technology, affordable technology, to deliver this idea. So we had to wait until some key, I guess, points we had to reach. First one was the chips. Chips were not really that cheap in older days, especially in 80s and 90s. I remember I used to have like 286, 386, 486, and the CPU wasn't really that cheap in those days. So we had to wait. It was probably 2010s, I will say, that chips price actually start to be affordable, so we can actually use them in like IoT devices. Second thing we had to wait was the connection. Wi-Fi wasn't really that common in older days, so we had to wait Wi-Fi to be a more affordable and more common connection. The last thing we had to wait was the evolution really from the connection, which is the IPv4 to IPv6. Basically, with IPv4, we did not have enough IP addresses to, actually have this many IoT devices. So that was really a turning point for IoT, and that was, I believe, in 2011 this happened. From that moment, really nothing was holding IoT to kind of go really crazy from that point. So we had CPUs, we had connection, we had enough IP addresses, and from there, really just IoT idea kind of just exploded. If you look at the history, the first IoT device was a Coke machine. It was a vending machine. It was in one of the universities. So what they did is they put a sensor in this machine and they connected to their local network, and they were able to check the temperature of the vending machine from the computers. So this is really the first IoT device we had. From that moment, it was 1990, John Romke here actually connected his toaster to the internet by using the TCP/IP protocol. As you can see, he's really excited out there, and he was able to control, how many minutes the bread was going to actually stay in that toasting machine. That was 1990. That was the first TCP/IP connected device. Then things get a little bit more crazy. We had first web camera, 1991. Again, another university. I believe this was University of Cambridge. The lab students, whenever they go to the lab, the coffee machine was always empty. They said that how are we going to solve this problem? They put a camera, and the camera was actually watching the coffee machine, and it was taking this picture like 2-3 times per minute, and it was sharing with the lab computers. So whenever actually they needed coffee, they could actually see and go and make more coffee. Right? Anyway, so that was 1991. That was the first web camera. Then probably one of the most complex devices came in 2000, and that was a refrigerator. It was 2000, and this refrigerator could do a lot of things that many people did not need then. For example, you could actually do video chat with it. You can do messaging with it. There was like an electronic pen. You can even watch TV on it. That was 2000. The problem was, well, not many people needed really this technology, and on top of that, not many people had that much, really internet in those days. And also, it didn't help that this actual refrigerator was $20,000. So, product failed, but that was a really big product for 2000. Come up with some idea like this. Then I guess it's gonna make sense. So if we try to understand what is an IoT, it's a bunch of sensors you put on like in a board, and that board has like CPU and memory, and from that moment, you are sensing whatever you are trying to kind of do with that board, and from that moment, you are actually sharing this data on internet. There's a lot of possibilities out there you can do from that moment. Business loves it because you can actually catch the problems before it happens with all the sensors. And on top of that, you can analyze it and you can try to proactively fix the problems. Business loves this. If you look at the numbers, as I said before, it was 2011. We had the evolution from IPv4 to IPv6. You can actually see the numbers going exploding here from 2012 to 2020. 8 years. The number out there actually is in 2020. The estimate is we have 50.1 billion IoT devices out there. Billion is billion, which is a crazy number. So probably if you're going to say that, what are those devices? But most of them is, I will say, probably smartphones. Everybody has the smartphones, but even the smartphones, really, that number is kind of crazy. If I try to represent this number to you in a little bit different, look at this one. We have 7.6 billion people on Earth, but we managed to actually have more than 50 billion connected devices, IoT devices. That makes 6.58 device per person. I think this number is much higher than that because, not everybody actually has internet on Earth. Not everybody has this technology. Not all the countries has it. So if you actually put the people who has the technology, that number is much, much higher. And if you think about it, it's kind of crazy too. It's kind of scary. Like all those devices are all over the places. Some of them is listening us. Some of them is making decisions. And we have more than 50 billion of it. If we look at some of the other charts here, if you're going to try to work on IoT devices, so probably the application you are going to write or you're going to work on is going to be in one of those. So those are the residential devices. So as you can see, the biggest one is the smartphone, which really is not a big surprise. But really, there's all kind of stuff here. You have tablets, you have smartwatch, and smart speakers are pretty popular here in the United States. You can kind of order things, you can talk to them, they will talk you back, all kind of things. You are going to work on more like industrial, then the chart changes to this. So the largest one here is the smart city. If you are from like one of those big cities, for example, they help you in traffic. They actually watch the traffic, and they are able to computers able to change the lights from red to green, green to red, depending on really the cameras. They can make the decisions. When you go to the airports, they try to find you empty parking spot for you. There's like usually there are like lights green or red, and it tells you which spot is empty, so you can actually go and park easily. We have connected cars. They can now actually drive them very easily now. So let me catch up with this presentation here. So as you can see, we have the smart city, that's the highest one out there. And we have the connected buildings, connected industry. We have agriculture, which is actually we are watching all the plants and all kind of items. So there's a lot of items here that you can actually work on, and there's all kind of opportunities here for sure. So what about the connections? So whenever you have the IoT device, that's the first thing probably you need to worry about. Like, how am I going to actually make this IoT device connect? So first option, of course, that's going to depend what kind of solution you are running. And the first one is going to be the option that high power consumption, high range, and high bandwidth. You might need that if you are actually trying to share a lot of data and you need to reach like anywhere on the earth. Best example for this one is really the cell phones, right? If you have a cell phone, you have to charge it at least once a day because it's using a lot of power, but it has a high range and high bandwidth. That's an option. It's an expensive option. The second one is low power consumption and low range, and you have a high bandwidth. That is usually the Wi-Fi and the Bluetooth. Probably, I will say this is the most common one and much cheaper than cell phone. So all you really need is, you just need to put a router in some area. As long as you have the internet, your device can connect to the Wi-Fi, and you can just whatever the IoT is sensing, you can just share it very easily. Third option you have is low power wide area network. So it was kind of new to me when I was actually creating this presentation. And this is mostly for if you are sharing really small data. I would say maybe like, for example, agriculture, you have a bunch of sensors. Maybe you are trying to, figure out what's the temperature of the soil or things like that doesn't really change that much. And also the size of the data is limited. And you can actually go with the LPUN. That's a low power. We have a high range, so you can have the device out there. Maybe from miles away, you can actually get the device's signal, and it is a low bandwidth. So those are the options currently you have. Perfect network connectivity option will be probably it should consume extremely little power. It might have like a huge range, and it can transmit really large amount of data. This definition I just gave you, it really doesn't exist yet. Maybe one day, but those are the options we have today. The second issues you are going to have with the IoT devices, this is a very, very common problem of everybody, is security issues. Main reason for the security issues is I said, we have more than 50 billion devices. Now, much easier to just like hard code the password and forget about it because really not easy to manage that many devices. Also, we have those devices, they are pretty, in a good kind of shape, but still they are not really that strong for, advanced encryption and other stuff. So even you want it, you might not be able to do this because, your IoT device might not be strong enough to handle that. So Those are going to be probably two challenges you are going to have if you are going to work on IoT devices. Now, let's speak about the IoT Hub. This is a service from Azure. And this kind of helps you, all problems that actually I'm telling you, this is going to help you with some of them. For example, with the security, this is going to help you because to connect to Azure, you need some kind of standards and some kind of encryption. So this is going to actually help you with the security. This place is going to be your central hub. All of your IoT devices are going to actually connect to IoT Hub, and you're going to have a chance to send them back signals. And all the messages is going to come to IoT Hub. So you can, from that moment, you can create pipelines and move data, other services or features if you like. This is very scalable. So if today you have 1,000 devices, and maybe next year your business is going to boom and you're going to have 10,000 devices, guess what? IoT Hub can handle that easily. All you have to do is change your plan, and you can go scale up and scale down very easily with the IoT Hub. So here's the plan. In this, actually, when I was playing with this, I was working with the free one here, the device, the plan. As you can see, we have the price per IoT Hub. I'm using the edition type free. And as you can see, there are two things you kind of need to look at. The first one is the number of units and number of messages. So as you can see, for the free, I have 0.5 kilobyte JSON document. That's my limit. And I can send 8,000 messages per day. That's free. That's more than enough for me. And as you can see, if you want to scale up and scale down, all you have to do is you have to change the edition here and fine from there. Also, when I said, you send the data to Azure IoT Hub, from there, okay, IoT Hub got the message. Then what, right? Azure actually gives you all kind of options here that you can create pipelines and you can do stuff with that documents. For example, we have Event Grid. Event Grid enables your business to react quickly to critical events in reliable, scalable, and secure manner. You have logic apps. That's mostly for automating your business process. It's almost looks like kind of like an SSIS out there. We have machine learning. So whenever you send the messages, you can actually learn from that and create AI models, and you can make decisions on those messages that you are getting. We have stream analytics. Well, if you have a lot of data, a lot of messages coming in, it might be a challenge to analyze this data because it's just too much. You can actually use Azure Stream Analytics to run real-time analytic computations on the data streaming from all of your IoT devices. Pretty easy to connect those to IoT Hub, and that makes the Azure a great place great platform for IoT devices. Now, we covered the IoT Hub. We have another IoT Hub kind of feature here, which is IoT Hub Edge. So IoT Hub Edge is a little bit different than IoT Hub. The biggest difference is we are giving more responsibility to the IoT device. We don't have to wait to get the message to respond to this message. So IoT, the IoT Hub Edge device can make decisions itself rather than we kind of go to IoT Hub and wait for it to make decisions for us. That means whenever a network problem happens, well, first of all, we don't lose the message because we can store the messages in our device. Also, it's going to be much faster because our device can actually make decisions itself. To a point, so they are still responsive, local changes, and more reliable because it can actually still work in the offline periods. If you want to actually use the IoT Hub Edge, you need to kind of know about the containers, because that container technology, because all of the applications that you are going to actually push to run in the IoT Hub Edge device is going to be running in containers. So you're going to go to IoT Hub Edge on Azure, and you're going to pick an application and you're going to push it to your IoT device, and all that application is going to be in containers, and your device is going to actually download them for you and run them for you. So I think we are in shape to talk about the Azure SQL Edge now. So we covered kind of like a history of the IoT. We know there's a lot of opportunity here. I say that we have like 50 billion devices. Imagine that 5 or 10% of that device is going to have SQL Edge on it. That's a big number. Somebody has to manage them. Somebody has to develop on them. So we covered the IoT Hub, which is going to be our central hub to receive data, send the data. Now, how about IoT? How are we going to actually install the SQL Edge? What is SQL Edge? If you look at the definition of SQL Edge, it is really the SQL Server. Currently is the 2019 on Linux version, but the definition says that the latest version of SQL Server. So right now it's 2019, but when the new one comes up, it might change. So right now it's 2019 of Linux version. Microsoft suggests that you should have the Ubuntu 18.04 operation system to install the SQL Edge. Also, when I say SQL Edge, it really doesn't come up with all those features. Like it doesn't come up with SSIS, it doesn't come up with SSRS, all kind of other components. We are really talking about the database engine only, and not the 100% of database engine either. Like it's actually missing like maybe file stream, the files, and it's missing like in-memory tables. So it's not like 100% either. You can check out the website of Microsoft and you can see exactly what is not included. But as a developer, really, I think it's missing. Mostly, I will miss maybe the in-memory tables. You are going to need a 64-bit processor. That's where actually that trick comes up, because until now, everything was working on x64-bit. Now, actually, it works on ARM64. That means that I can install this device, install this SQL Edge into my Raspberry Pi, which is great. You are going to need at least one CPU and 1 gig memory. As you actually fire up SQL Edge, you are going to need at least 450 megabyte memory. So I will suggest to have at least 2 gig RAM. But depending what you are trying to do with the SQL Edge, you might need more for sure. This doesn't sound that bad, but as I said before, you're not going to have only one device, right? You're going to have many devices, so that can get costly very fast. Also, Azure SQL Edge, is missing a lot of items if you compare to regular SQL version, SQL Server version, but it has actually some stuff that none of them actually has to. For example, it has SQL streaming. It's really based on the same engine that powers the Azure Stream Analytics, and it provides real-time data streaming to SQL Edge. So, if you want, you can save the data in your database in the device, but in some way, you kind of need to move that data to Azure SQL Hub. So, you have some options for that. Second one is that's a T-SQL function, date bucket. It's really for time series data analytics you can use. And we have a machine learning capabilities through the Onyx runtime, and that's included in the SQL engine. And as you can see, when you look at the price, well, kind of like cheap when you look at it first time. If you want to go pay as you go, it's $10 per device per month. If you want to be reserved, it can go down to $60 per device per year. When I show this to DBAs, most of the DBAs try to actually find a way that they can actually use this model to do other things rather than IoT. So Microsoft forces you to actually use this device for only IoT only. So you kind of need to be I guess, it has to be used for IoT. You cannot use for anything else. Now, if we try to actually look at this in a little bit, I kind of compare the SQL Edge really a pacifier, because if you think about it, IoT device constantly sends signals, right? It's like a baby. It's like a crying baby. It always needs some kind of attention. So, well, as a parent and as a developer, sometimes you might need some peace. And with Azure SQL Edge, actually, it kind of works like a pacifier. So you can just put the pacifier on the IoT device, and it can actually start to give you some peace. And you have two versions of the specifier. The first one is the 32 gig the memory version. It can support up to 4 cores. That's the Azure SQL Edge developer. And we have the production version. It can support up to 64 gig memory, and it can take 8 cores. So kind of works like the specifier if you really think about it. Now, what actually makes this device ready for Azure SQL? So this is the place that actually things get a little bit tricky. You have to install IoT Edge Runtime to the device. And that might be a challenge depending what type of operation system you have and what kind of hardware you have. This runtime actually turns your device into IoT Edge device, so you will be ready to connect to Azure with your device. It installs and updates all the workloads. It takes care of all the security standards that we covered earlier. You will have a lot of modules, which is the containers. So whenever you push a container on the device, it will actually download it for you, install it for you, change the settings for you. It will report all the module health. So if something is not working, it will report it back there. You can see on the IoT Hub. And really just manage all the communication for you. We have two modules for this. The first one is IoT Edge Agent. This is the one which takes care of all the modules that you send. So SQL Edge is going to be a module, right? It's going to be in container. When you push it, IoT Edge Agent is the one which is going to download it, install it, and configure it for you. Also, IoT Edge, if there's any kind of problems happening with it's going to report back to Azure IoT Hub. Those are the error codes you can see here. That you might actually see in Azure Hub, IoT Hub coming from your device. Also, we have the IoT Edge Hub. That's really work as the local proxy of IoT Hub. So when something goes wrong with the communication, this one just works like applications already connected to IoT Edge Hub. And this one is actually handling all the communication to the cloud. Now, here's my device. I bought Raspberry Pi, I will say, probably last summer, after I heard that, we are going to have a new SQL version coming up just for Raspberry Pi. When you look at what actually it comes up with, it's kind of amazing. With that, small thing, small box can have all those items that you see on the screen. For example, it has RAM. I think I have the 4 gig RAM. It has a Wi-Fi. It has 2 HDMI, so you can actually connect 2 monitors on it. It has display port, camera port. It has all those devices, which was kind of amazing for me. The only problem I had with this is its operation system was Debian Linux 10 based. And if you look at the requirements from the Microsoft, they support that, but they really suggest that I should have the Ubuntu rather than that. So I said, okay, I'm going to go and download the Ubuntu rather than try to make this work, which I did. But that was kind of like, a mistake on me, because if you look at the requirements from the Microsoft, they are really looking at the version 18.04. So when I actually tried to download the Ubuntu, there was like a newer version. Sorry, I think it was like 2004 or 2104, something like that. So I was like, why I need 1804? I'm gonna get the latest one. Why not? I did, and I put on the device. I'm gonna cover the problem in a little bit why I did that. So other thing about this device is, I say that this actually device supports 2 monitors, but who wants to kind of waste 2 monitors for just, for this device? So you are gonna, need to kind of connect this remotely. And what I did is I just take this device and connect it to my router, connect directly, and I can actually remote in and make things much faster for me rather than wasting a monitor. To do that, well, you are gonna need the remote control for that. I'm not really a Linux guy, so I do most of the stuff in Windows. So that was kind of like a challenge for me to configure this. But I find out that, we are going to use the SSH for this, OpenSSH, to remote into the device. And I look at some of the options. There are like third-party options you can download if you like. But in the meantime, actually, Windows comes up with OpenSSH in the system. So you don't really need to download third-party application. So I'm going to show you actually that first how to install OpenSSH by using this. So the first thing you are going to do here is you are going to open the PowerShell. And as you can see here, all I'm doing here is I'm adding a Windows capability, and I'm saying I want to open SSH client. I'm showing here that server too. You don't need the server. I'm just showing that's available. And when you actually make that, we are making the SSH enabled in our system. So this is the first step. We actually make the SSH available. From that moment, we have to do a couple of other things. The first thing we have to do is we are going to start the service. Then we are going to make the service available automatically when the computer comes up. Then we are going to actually check firewall is actually blocking SSH or not. So that's the whole kind of things I'm doing here by get net firewall rule. You can see that nothing is getting blocked, so I am in good shape here. Now, after this is done, I am ready to connect my device by using SSH from Windows. And I'm happy because I don't have to kind of deal with Linux that much. I'm still in Windows. Yes, I still need to kind of learn the commands, but at least I'm still in Windows. Now, in here, as you can see, the next step, all you have to do is use the SSH command. First one is the username, which is this is the IP address of my device. If your device is set up right, it's going to ask you the password. You're going to enter the password. Then all of the commands that you're going to run, actually you're going to run them in the Raspberry Pi or whatever Linux device you connected. So we are in good shape here. So next, we need to actually install the runtime. So to do that, that's going to be a little bit tricky. First, we have to kind of look at them. Until now, we used to have this problem with the 32-bit and 64-bit applications, right? So if you have a 32-bit CPU, and if you try to run a 64-bit application, guess what? It's not going to work. We have the same situation here, but it's a little bit more complex here because there are more options rather than just 32 and 64-bit. Now we have to worry about the ARM CPUs. So whenever you are trying to download any kind of application for your device, in my case, it's the Raspberry Pi, you want to be sure that what type of CPU you have, so whenever you are downloading, it's actually respecting your CPU. Main reason I'm telling you, because whenever it doesn't, and if you download something, wrong, message you are going to get from the device is really not going to be user-friendly. It's not going to tell you, what, this application you are trying to run my CPU really is not built for this. I wish it was like that. It doesn't. You will waste a lot of time to figure out what the problem is, especially if you are not familiar with the Linux. That's really what happened to me. So don't forget your architecture of CPU and download the right files. That's my advice. Next. So as I said before, Microsoft has its own kind of requirements, operation system requirements when it comes to the IoT runtime. Now, the first thing as I said before, you need to get familiar with the containers because that's how the IoT, the SQL Edge is going to be in. And you kind of need to know how to list the containers, how to run them, how to stop them, all kind of stuff. So first, probably you want to get familiar with that. Second one, which I learned this in a hard way. When it comes to the SQL Edge, there are two tiers from Microsoft that they have like a support levels, tier 1 and tier 2. Now, if you have Ubuntu 18.04, you are in tier 1, for example. Microsoft supports everything, and they give you a script, they give you the repository, they give you the manual. So pretty easy to install if you have here the 16.04 or 18.04 Ubuntu. My case, that was not the case, because what happened is I say, okay, I'm guessing I should get the latest Ubuntu, because I guess we want to get the latest, right? And on top of that, it's free too. So when I get it, as you can see, my version was, I believe, 20.04. So as you can see, my 20.04 is not in this tier 1 support. It's actually in tier 2 support. This one, actually, you can see it has much more options. 20.04 is in the bottom out there right now. I don't know if you can see it. So this chart tells you that all the operation systems you see here, well, uses the IoT runtime will run on them. The only problem is Microsoft does not give you any manual, any repository. You are alone. You have to put the runtime in this device yourself. Microsoft knows it will work, but they don't give you a manual, and they don't really help you that much. That's where I was. In this presentation, I'm going to show you tier 1 and tier 2 how to install actually the runtime to your device to connect to Azure IoT Hub. Now, let's continue here. The next, I'm going to show you, if you have tier 1, it's going to be pretty easy to actually get this information. So let me go here. If you're in tier 1, what probably you are going to do, if you look at the manual, you're going to go this URL, and you're going to find your device, and then you're going to actually download it. Well, sounds easy. No, in Linux, probably it's easy for you too, but it was not that easy for me. First of all, we are in Linux, so you cannot just really, not easy to go and download and kind of, I guess, register this repository. So what you are doing here is you are using CURL. CURL stands for client URL. So what I'm doing here is I'm really going to this website and downloading this prot.list file, and I am moving to my local folder, Microsoft prot list. So that's what I'm saving it as. That one actually has all the repositories. That one has all where the files are. Microsoft gives us all the information, so we don't have to go and find them manually. Next thing I'm doing here, I'm just registering this file that I just got from Microsoft. So whenever I want to install it, the Linux will know everything about it. So sudo is, I guess we can say, that works like run it as admin in Linux. I think it stands for super user do. CP is for copy. So what I'm doing is I'm copying the file, just the copy of the file that I just downloaded to this folder here. That is it. Or 18.04. First step you're gonna do. Now, next step is going to be for the PGP file. So you need this file to connect to Azure. And this one applies to tier 1 or tier 2. It doesn't matter which version, which tier you are in. You need to do exactly the same thing. I'm doing the same thing here. As you can see, I'm downloading the file from Microsoft, and I'm putting in all the other files, the PGP files in the Linux. So this has to exist in that folder. And you need to do this step if you want to connect to Azure successfully. Is going to be container. As I said before, everything works in container. So we kind of need some kind of container system so it can handle all those containers. To that, actually, Microsoft selected the Moby engine, and Moby engine is open source. So you don't have to, I guess, pay for any kind of licensing for it. So what I'm doing here is already the Linux should know where this file is because it's on the repository already. So you are saying the update your repository here, the first line. Then you are saying install the Moby engine. And the third one here is it just configures it so it can actually work with Microsoft repositories. That's really applies to tier 1 and tier 2 too. And you must do this step if you want to be able to, I guess, download and run the containers. Now we are ready to install the application, which is going to actually make your application the IoT device, an IoT Edge device. You're in tier 1. This is your last step. After this, you are done if you are in tier 1. So what you are doing here is you are saying super user do, and you are saying install IoT Edge. This is IoT Edge. This is the first step. If you remember, we get that file from Microsoft and we register in the repositories. By just running that, Linux knows where the IoT Edge is and it installs it for you and for you. If you are not in tier 1, run this comment and it's going to say that I have absolutely no idea what you are talking about. And from that moment, you are alone. Well, I was alone. So, but if you're in tier 1, that will be your last step, and you will be ready to register your device after this point and put your connection string out there and, really connect. If for any reason, if you want to connect or use a different version, IoT Edge Runtime, you can do in the second part here. As you can see, you can define which version you want, if you like. Now, unfortunately, my adventure was not this easy. So this one did not apply to me. I'm in tier 2. And tier 2, I had to figure out first why this thing is not working. So it looks like what happened here is, like in Linux, everything is files, right? So if you want to change a setting, usually it has a file just in some kind of special folder. In my case, this is the SSL, for example. If you want to enable the SSL, you need an SSL file in a special order, a special folder. Now, and also what happened here from, I think, 1804 to 2004, Linux actually changed this SSL file. It upgraded the version. And 1604 and 1804 is actually looking for this file, which is the libssl 1.0.0. In 2004 and later, they upgraded this. So this file doesn't exist. So that is the main reason that actually the whole package is failing, because there's a reference to this file, and when the Linux cannot find this file, it just says, I'm out, I'm done. So the first thing we had to do to actually make this run, we had to download this file. But as I said before, when I was talking the CPU architectures, as you can see, this is the same file. At the end of the file name, you can see that it specifies which CPU is this for. So you want to be sure that you are going to download the right one, because if you download the wrong one, which I did before, it took some time for me to figure out what the error was, because it wasn't a user-friendly error. So in my case, as you can see, I am downloading the one ARM64.deb. That's the one I was downloading. So first, we get this file. Now, the next, we have to install this file. As you can see, I just download the file by using the C URL again, and it comes up as a .deb file. I guess we can compare that to zip file in Windows. And you have to depackage the file. And I'm doing that in the second item here. As you can see, I'm saying run as an admin, depackage it, and I'm putting in a folder here. I named this file as test. So after this, it's going to get open and it's going to put all the files out there. Then you can actually install it. In here, as you can see, I am installing the file. So in this moment, I should have this file now. So now nothing is stopping me to run setup of the IoT Hub runtime, because this is the dependency that I did not have before. Now, after this installation, now I need to go and find the IoT runtime, IoT Hub runtime, because since I'm in tier 2, Microsoft did not give me where this actually the source is. So I look at it and it looks like it's on actually GitHub. You can go and download the latest version. In my time when I was doing this, there was the version out there, you see 1.0.1004. And I download this just the way that I downloaded the others. So I use the C URL. Then I install it. Here's the what it looks like when we try to install it. And really, if you see the screen, you are almost done with this process. So we have the SSL file and found that file. Installs the IoT Edge Runtime here, as you can see. And when it's completed, we are in shape to actually start to connect to Azure. So when this is completed, next step is going to be actually registering your device. So your device is ready to connect to Azure. You have everything required in the Raspberry Pi. But now you have to register your device. So whenever you try to connect to Azure, Azure will kind of know who you are and your device will have the connection string, so it will know where to connect. So before you register first, you kind of need to start the service for IoT Hub. It's pretty easy. You just your subscription information, you give a name, that's it really, and you start the service. From that moment, you can use the Azure Portal to actually register your device, or you can use the VS Code. If you like to use it, you are going to need that extension if you want to register by VS Code, or you can do by the Azure CLI, and you are going to need that extension if you want to do that. So I'm going to show you here actually how to do this in Azure Portal. Now, I am ready, so I go to my Azure Portal. But there's one more thing though. This is the, I guess, how are we going to connect the Azure Portal? Since I'm doing everything in dev, I want to do this in kind of like a short way, and I'm going to pick the symmetric key authentication. This is almost like they give you the connection string, and as long as you have the connection string, you connect. But if you do this in production, probably it's a better idea to get like a X509 certification authentication. That takes a little bit longer, but really the process, how you're going to put this information is really the same. You are going to really open the file, the config file, and put that information in your config file. So from that moment, your application, the runtime will know where to connect. So I'm going to go with symmetric key authentication because it's much easier to do this, especially I'm doing this in dev. So that's what I'm doing, what I'm going to do. Now, register my device. As you can see here, I go to the Azure. And in the left side, you can see that I'm in IoT Edge, and I highlighted that icon here. It says Add an IoT Edge device. So when you click that, you are going to actually see this icon, is the window is going to come in the right side. Then I ask you what the device name is. You can name it whatever you like. Second thing is going to be the authentication type. That's the one that I just talked about, the symmetric or the certification. In my case, I am picking the symmetric. Then really that's it. From that moment, you can just click OK and your device will be created. Now, after your device is created, you have to go and find its connection string. And to do that, you just need to pick the device that you just created in that list. That will be on a list there. And as you can see, you can find the connection strings here. So all you have to do is just copy the primary connection string from here. And you need to go back to the Linux and open the file named config.yaml and find the section for the manual provisioning and just paste that connection string here. So if you look at this command though, so we are running as admin nano. But nano is like almost like a notepad, I guess you can compare to notepad of Linux. And we are opening this file. We are pasting the connection string here. Then we save the file. And from that moment, we can actually restart the IoT Edge. That's the runtime that we just installed. Then you can look at the status of IoT Edge. Everything should be, I guess, green and connected when you run that IoT Edge. That's what you should look for when you run. As you can see, my containers can run. It can connect the Azure IoT Hub. Everything looks good. So I'm in good shape here so far. Next. I'm ready actually to install SQLH. So far I haven't even touched the SQLH yet. All I did is I made the environment ready for which is going to accept the SQLH. To find the SQLH, I go back to my device, which I named RASP4. And this is the same place that I got my connection string, right? So all I'm going to need to do is I go and click on that set module. When you click that, you are going to actually see a list here. You need to go and find the SQLH in this list. I'm picking the marketplace module because that's a Microsoft module. And after you pick that, you're going to just search. I just searched by the SQL. As you can see, we have two versions, Azure SQLH Developer and Azure SQLH. This is the production version. So I'm picking the SQLH Developer here. And I just click OK. From that moment, what's going to happen here is, for this container, I need to give a little bit more details. Because, well, what's going to happen here is when I push this, the module is going to get downloaded to my IoT Hub device, which is Raspberry Pi in this case. But to actually be able to run the SQL, you kind of need to give, SA password. To be able to connect. So in here, this is the place that I am defining my SA password, and there are some other configuration like the accept ULI and other stuff. So I put them yes here. So desired value is yes. Those are the ones that I can change. And reported value after you push the SQLH to the IoT device, gonna report back whatever it has. So all those things has to kind of match. So you can actually see here. So I guess short term, I just the SA password so my SQLH can start and connect after it's installed. So from that moment, when I'm done with this, what's really going to happen here is the IoT Hub Edge is going to actually push this JSON file to my Raspberry Pi. Raspberry Pi is going to get the message. It's going to see that I want to install SQLH. It's going to download the SQLH, the module, and it's going to start the configuration I just specified here. And everything is going to run. Everything is going to start. Then from that, that process might take time. I don't know. It depends, your network, how fast the internet is. So from that moment, you can just run this IoT Edge list, and this will list you all the modules running. So if you don't see the Azure SQL Edge might kind of try this every 5 or 10 minutes, depending on your connection. It might take some time to actually download and start the SQL Edge. In my case, in here you can see SQL Edge is running with other modules. Those two modules are the runtime modules that required to run the SQL Edge. And everything is working here in my tier 2 support Raspberry Pi. So let's see how we are doing with time. It looks like I have 10 minutes. So let me show you how to connect. So right now, actually, this is running on my Raspberry Pi. So let me share my screen with you. Now, as you can see, I connected to my Ubuntu here. And as you can see, I put the SSH Ubuntu. This is my IP address. It asks me the password. Everything is fine from that moment. And you can see it just gives me some information about my Raspberry Pi after I log in. Then I can actually go and see IoT Edge list. This one actually gives me all the list of modules running in Raspberry Pi. And as you can see, SQL Edge is one of them. And it has been actually running for longer than 3 weeks, but I guess that's all it can show here. So looks like I'm in good shape. I connected to though. Now let's try it. I can use SSMS. I can use any kind of client, really, which can connect to SQL Server. So what I'm going to do here is I'm going to say connect to database engine. This is the IP address, and this is the port I'm connecting. This is the SA, and the password I just defined in Azure IoT Hub. Now I can click connect. As you can see, I'm connected. It's version 15.0 2000. And from this moment, you can really do anything, right? We are in the SQL Edge, but as you can see, I created a database here named sensors. So I guess my next step here, what I need to do here is probably create my own container, something very simple, maybe buy some sensors and they can actually send some data and I can actually start to push them in my database here. So what I had to do right now, I don't think I have any tables. But as you can see, you can even see we have even graph tables here, so which is good. What I can do here is, let's say I have maybe one oxygen or whatever. So I can just create a table here. Say go to sensor, and let's say we are gonna have sensor ID, the integer, and maybe sensor value. You can do whatever in this point. So if I run this, let's say we are going to do this in sensors. And run this. Now I have my table. Another table I have, right? So just refresh this. I have my table here. So I ready to kind of maybe create my .NET Core application, get the data from sensor and push in this table, right? So rather than pushing this message every time to IoT Hub, now actually I can save my data here and maybe even use it in my AI modules and all kind of stuff. So this is great. Everything is working fine, and it's kind of amazing that actually I'm running this in a Raspberry Pi, and I can run all kind of queries and all kind of stuff here. So, all right, I think that's all I have for you today. Thank you for coming to my session. I can answer any of your questions if you have. If not, thank you again for having me. And here's my contact information. If you have any questions later, reach me and I will be happy to answer any of your questions later too.